As part of the function design recipe, we include 1 or 2 example calls on the function in its docstring. The last step of the function design recipe is executing those function calls. Up to now, we've been executing the function calls by copying and pasting them to the Python shell and then comparing the value returned with the value that we expect. In this lecture, you'll learn about doctest, a Python module that allows us to run these tests in a more automated way. On the right-hand side of the screen, there's a module named vowels.py that contains 2 function definitions, collect vowels and count vowels. Each of those functions has 2 example calls on it in its docstring. To execute the example calls, we need to run the module and then copy and paste each function call to the Python shell. Once the function call is executed, we compare the value returned with the value that we expected to make sure that they match. Let's do this for the other 3 as well. Rather than calling each example one at a time, it would be nice to be able to run them all at once, and Python has a module named doctest that allows us to do just that. We begin by importing doctest, and then we call doctest's function testmod to run all of the tests for this module. What we see here are the test results. 4 tests have been executed, and in this case, all of the tests have passed. A nice feature of doctest is that it does the comparison of the value returned by the function call with the value that we expect automatically. This makes the testing much less prone to human error since we aren't doing the comparison of those 2 values ourselves. Let's consider another example. On the right-hand side of the screen, there's now a module named divisors, which contains 1 function named getDivisors. GetDivisors has 2 parameters, a number and a list of possible divisors of that number. The function returns all of the items from the list that the number can be divided evenly by. For example, for the number 8 and a list of possible divisors, 1, 2, and 3, the function call would return a list of divisors 1 and 2. 8 cannot be divided evenly by 3, so 3 is not included in the list returned by the function call. This function has another example in its docstring as well. Let's run both of these example calls by running the module and then running doctest. The message that we get back from doctest this time is much longer than it was for the vowels example. For the vowels example, all 4 test cases passed. In this case, the 2 example test cases were executed and 1 of them failed. A test that fails is one for which the actual value returned by the function call doesn't match the value expected. In this case, it was the second example call that failed. For getDivisors with the number 4 and possible divisors -2, 0, and 2, an error occurred when executing the function call. The error was a 0 division error. Somewhere in our function, we divided by 0. Let's look more closely at the code to see where this would have happened. We can see from the error message that the 0 division happened on line 15, which is this if statement header. This Boolean expression takes the number and divides it by the possible divisor to see if it divides evenly. At this point, we can look at our example. There's a 0 in the list of possible divisors, so that means that on line 15, we're dividing the number by 0. Now that we've found the problem, it's time to fix it. We need to ensure that number is only divided by non-zero numbers. To do this, we'll add an additional Boolean expression to our if statement. As long as the item is not equal to 0 and the number divides evenly by that item, will it be added to the list of divisors that's returned at the end of the function call. Recall that Python evaluates the AND operation using lazy evaluation. That is, If the first operand is false, the AND expression is false, and Python does not go on to evaluate the second operand to the AND. In other words, when item is equal to 0, the expression on the right-hand side of the AND won't be executed, so num won't be divided by 0. It's now time to rerun the tests. We'll rerun the module so we get the latest definition of this function, and then run testmod from doctest module. Although we no longer get the 0 division error, the test case still fails. We expected to get a list with integer 2, and instead we got a 2-item list with -2 and 2. This time, there isn't a problem with the function definition, there's a problem with the test case. -2 is the divisor of 4, and it should have been included in the list. We'll add it now. Next, we need to rerun the module and retest it. This time, both of the test cases pass. Instead of importing doctest and running testmod in the shell, we can do it from within the divisor's module. Now, each time that the divisor's module is run, the test cases are also executed. If the test cases pass, there's no output in the shell. No news is good news.